Hi everyone. Let me share my screen. I'm sorry. This is step two. Do please let me know if you're able to see my screen.
Yes, sir.
Okay. Great. Hey everyone. Good morning, good afternoon, good evening, everyone. And thanks ICCMB for the introduction and having me here. Respected speakers and audiences. I would like to introduce myself. My name is Karan Kumar Ratra. I am an engineering leader specializing in large-scale distributed systems, e-commerce platforms, and fulfillment technology. Over the past 17 years, I have worked across telecom, fintech, and retail industries, leading the design and implementation of mission-critical systems that now supports millions of users and transactions worldwide. Beyond my industry contributions, I am an active contributor for the global technology community, research publications, international conferences, and reviewing them and judging the innovation and technology awards. Today, I would like to share my insights on the most impactful challenges any modern digital e-commerce platform faces and how organizations can move beyond these traditional customer support models and leverage system-triggered customer self-remediation platforms to transform their fulfillment exception handlings at a global scale. And like everyone in this room, I do spend a lot of time thinking about the what happens when these systems don't work perfectly. Because at global scale, they always fail sometimes. And the question is not whether the failure happens, but the question comes to my mind is how does the system recover about it and how do they solve it? And I want to talk about a specific class of failure today, which is the fulfillment exceptions in e-commerce platforms, where an order that can't be delivered as promised, and I want you to explain the fundamental rethinking of how we have handled it, not improving by the call center or by hiring more agents, but by inverting the model entirely. So the system itself detects the problems, engages the customers proactively, and empowers them to resolve the issues in the real time and without any human interventions. We call this as a customer self-remediation platform, and I believe it represents a genuinely new paradigm, not just for retail, but for any industries where complex service delivery systems produces exceptions that can affect the end users. So with that said, let's get into it. Let me start with the problem that has existed from quite some time now and it still exists in most of the places. When a delivery fails under traditional model, the flow looks like the order has an issue. The customer discovers it, and usually by tracking their order or by seeing the delayed messages or by simply waiting for the package that never arrives. The customer at that point in time can call or chat with the customer care agents, and the customer care agent can investigate manually and then resolve them. And the customer still has to wait for agents to come back and respond with their manual actions. And every single step in that chain is a problem. First, customer bears a discovery burden. They have to find out whether their order has been delayed. They have to notice that something has went wrong. And second, every exception consumes time and agents are expensive. And according to recent reports, each customer service contracts cost between $6 to $12. And at millions of orders per day, even a small exception rate produces enormous cost to the organizations. The agent can typically offer one resolution at a time, and usually that's nothing but the refund. But the customer loses their product, gets the money back, but they don't get what they actually want or what they have actually ordered. And the deeper structural problem is that the agent capacity is linear. We can add agents one at a time, but the hiring and training cycles for them takes weeks or months. And the exception volume grows with the order volume. And during e-commerce order volume or during peak periods, it can surge overnight. And that mismatch is the core of the problem. And it cannot be solved by just adding more customer care agents. It requires fundamentally a different software architecture. And that's what we are going to touch upon today. To understand why this matters, let me give you a sense of the scale of any e-commerce organizations. Large-scale e-commerce retailers, which are processing on an average 3.6 million orders every single day, and at a 2% or 3% exception rate of fulfillment exception rate, which is a realistic industry estimates, that is between 70,000 to 100,000 delivery failures happening every single day in each retailer. And every single one of them or those failures are the traditional models, and it is a potential contact to the agent. That's not a customer experience problem. That's the system architecture problem. And it gets harder, not easier over time. As you see, the US e-commerce grew 44.5% in a single quarter of 2020. That's the largest Census Bureau has ever recorded. We can think of this as a COVID expansion because that was COVID peak period. But during that period like that, exception volumes can spike proportionally. And hiring pipelines, training programs, and contact center capacity cannot scale at the same rate. And this gap can actually widen because the order volume can grow exponentially overnight. So modern e-commerce platform also operates across 5 or more different fulfillment channels. Excuse me. Channels. These channels are nothing but stores, distribution centers, dropship partners, marketplace sellers, or same-day delivery. Each of these channels has its own failure modes. So if you think the failure modes are complicated, in this case, the system has to detect and classify all of them. And doing it fast enough or to act before the customer even knows that something had gone wrong is the main challenge. And that's the challenge this architecture addresses. Sorry. Okay. Which brings to traditional models of self-remediations. So how do usually the customer right now does a remediation? Let's make a paradigm shift. Because the traditional model is where the customer discovers the issue. The customer contacts a support agent, an agent resolves it, and that's reactive. And it's costly and slow as well. Every step adds a latency in between. And at the end of it, customer may or may not get what they actually needed. But under the self-remediation model, the system can detect the exception before the customer even knows that, which means the system proactively engages the customer while the order is still in transit. This also means that the customer self-resolves choosing one of the 3 simultaneous options that we can give to the customer, which is either they can reschedule their order, convert to pick up their order to a nearest store, or cancel the order. And if you see in all of these 3 options, the support agent is not involved at all. And I wanted to sit with the last point that under the traditional model, every exception is an agent contact. But under the self-remediation model, most exceptions are zero cost resolutions, which means companies or organizations are not bearing a cost and customer is proactively notified. It is a win-win for customer as well as for the organizations. And the marginal cost per exception drops to essentially nothing because it is handled entirely by the software architecture. This comparison table that you're looking at captures 6 dimensions to this shift, and every single dimension flips. Detection goes from reactive to proactive mode. Timing goes from hours after failure, at the moment of failure, to in transit. And the agent requirement goes from mandatory to eliminated. Cost goes from $6 to $12 per contact to nearly zero. And the scalability goes constrained by the headcount to unlimited. We do not have any limited capacity now. It's unlimited. Because it's just the software architecture or the architecture code sitting on a software services. And this is not an incremental improvement. This is the architectural inversion. To summarize this slide, it's basically from agent-driven resolution to customer-driven resolutions enabled by all intelligent systems. So how does the system trigger remediation framework works? Now let me walk you through how it actually performs or functions. The system operates as a 7-stage pipeline. It starts with continuous order lifecycle monitoring, where every order state is being tracked in real time. And when the exception occurs, the stage 2 kicks in. That's the exception detection engine, which executes. And this is an event-driven step, and there's no polling, no batching. The moment the carrier or state changes or inventory signals a node failure or a shortfall or a routine failure is detected, this event gets executed. In stage 3 is the root cause analysis, where the system classifies what has went wrong and is this a carrier delay or weather event or inventory issue. So this could be any issue that can happen. But the classification matters because not every exception is eligible for resolution option. There could be some issues which could not be resolved by the customer and it requires a manual intervention. And that's why this is the logic where at stage 3, it tries to identify the root cause of these failures in real time. That leads to the stage 4, which tries to do eligibility evaluation, where the system checks, can this order be rescheduled, or is there a store nearby which has the stock available for pickup, or customer can directly cancel it. And these checks happens against the live inventory, live carrier state, and live store availability. Stage 5 is the remediation decision engine, and this is the brain of the system. It determines which option to present based on what's actually available. As seen in the stage 4, depending on certain situations, it can be available for pickup, it could be available for rescheduling or the cancellations. Basically, stage 6 delivers the proactive notifications. And this is a key moment where customer can receive the messages not because they complain, but because the system proactively identified the problem on behalf of the customer. That brings us to the stage 7, which is the self-remediation resolution. This is stage where customer picks in options and the system executes that autonomously without having any agent in this place. Which means once the customer wants to do anything, the system can execute on the customer's behalf, eliminating the associate agent role altogether. The available resolution actions right now customer can do is now reschedule to a new delivery window, convert to a pickup store that's nearby to the location of the home, or cancel and get an instant refund, or route to an alternative fulfillment partner. Basically, the customer has the entire control and there's no intervention of human in between. So the customer is directly interacting with your software and it's the e-commerce architecture. That brings me to the stage 6 about the reference architecture and orchestration layer. Here, I want to spend a moment on the architecture because one of the things I find most interesting about the system is that it's not a standalone application. It is an orchestration layer that sits across multiple enterprise systems. And if you can see in the image, every integration point is its own design. Every integration point has its own design challenges. If you check the stack in this image, at the top you have the order management system, which is the source of every order state and life cycle. Below that is the fulfillment systems, which has inventory positions, routing logic, etc. Beneath it, you can see the delivery and carrier partners, which could be the last mile execution, tracking feeds, etc. And these 3 layers are the foundation. And these 3 layers exist in every major e-commerce platforms. The self-remediation systems inserts itself as an event-driven layer on top of these 3 basic pillars, where the exception detection layer listens to the state changes across all 3 systems simultaneously. The remediation engine makes the decisions on what it hears, and the customer experience layer delivers the notification and self-service interface to the customer where customer can take certain actions. And the whole flow terminates once the customer has executed any action and taken the self-service actions. On the right-hand side, you can see the connected enterprise systems that makes this possible, which is order management for the cancellation authority, inventory systems for the real-time stock validations, logistics and carrier partners rescheduling APIs, and the customer experience layers for notification channels, financial systems for refunds, authorizations, etc. And at the last, analytics and ML for exception classification or outcome tracking. And if you can see from the complexities, none of these integrations are simple. Each of them is a separate contract. And the system only works if all of them work in real time in tandem. That's what makes this architecturally interesting and why it has been not replicated easily. And to summarize, this is not a feature, it's a platform where we are providing customer the self-remediation options without having any manual interventions and orchestrating between different complex systems in real time. Let me go to business impact. Right. So what is the actual impact for this? Let me separate the customer benefits from the enterprise benefits. Because the interesting thing about this model is it creates simultaneously values on both of the sides. For customers, a resolution can happen in under 2 minutes versus an 8 to 15 minutes on an average agent call. That's a self-service versus agent-remediated contact. The customer knows about the problem before they even have to ask. They have 3 simultaneous options instead of 1, and the companies with proactive service models consistently show that 2 times higher customer satisfaction scores than their reactive peers. And for enterprises, the self-service handles 8 to 10 minutes more interactions at the same cost as a single agent. Now, each agent contact that never happens is $6 to $12 saved. Customer who resolve using their orders and the customer who have wait for the agents at the cancel times scores higher rates, so which means ultimately organizations improve on their GMV, which is direct outcome. And not only that, it's also improving their net promoter scores. Now, I want to close this slide with the core insight that the self-remediation is the rare solution where cost reduction and customer experience improvement are at the same action. You don't trade one for the other, and automating the resolution makes it cheaper and faster for better simultaneously. Why this is beyond retail, and this is transferable pattern. So here's where I want to step back from retail entirely because I think most of the important things to understand about this software architecture is that it's a general pattern across any industry, not a retail specific problem. The pattern is a complex service delivery system produces exceptions that can affect end users, where the system detects before the user does, and the system proactively notifies the user. The user is presented by the self-service options, and the user resolves it without contacting the agent. And that pattern applies everywhere. In healthcare, a missed appointment, a lab delay, a prescription not available at patient's pharmacy, the clinic system could detect and offer patient self-remediation before even the patient even arrives. Instead of the frustrated patient calling the front desk, you can have proactive notifications and reschedule their appointments. Likewise, in banking industry, a payment failure or card decline or fraud hold, the bank system can detect at the moment it happens, and the customer is notified and offered self-service to dispute initiation or alternative payment options before even they realized. If you can apply the same pattern, it can be applied for travel and government services as well. The ultimate goal of this pattern or this architecture is the architecture is reusable beyond retail. It could be also be used in any digital transformation organizations. And the specific integrations might change, the contract might change, the internal systems can change, but the logic to detect, notify, and empower the customer is universal, which will definitely help your customers and organizations at the same time if you use this pattern. Which brings me to the future directions of this pattern. And let me close this technical part by talking a point where research and engineering community can take this next because the current implementation, as powerful as it is, it's mostly for retail. The first frontier is the predictive exceptions. And what we have built at the moment, failures can happen. The next generation of the system could predict them 6 to 12 hours before they actually happen. Think about what that means. If you notify the customer before the failure happens, you can offer resolution options while there is still a lot of time to act. And the research area is the time series anomaly detections on state signals, fulfillment node performances, weather pattern data, etc. And this is an open and important machine learning problem as well. The second frontier is a cross-platform standardizations, where right now every retailer, every carrier, every platform has its own proprietary exceptions.
To gift yourself with some rejuvenating concentration.
Sorry. So the second frontier is a cross-platform standardizations, and right now every retailer, every carrier, every platform has its own proprietary exception APIs, and there's no industry standards protocols for any productive fulfillment exceptions. So defining an open standard, similar to what we have like for OAuth, if we can define the open standards for remediations across industries, that would allow the entire ecosystems to interoperate. Okay. The third frontier, which could be taken in future directions, is we have ML models trained on customer history or product category or time of the day or location of the day or weather forecast data, which could help us to identify the problem very much ahead in the game so that customer can get a lot of time to act on those exceptions and rescue their orders or rescue their positions in any platform or domain. The last frontier is fully autonomous orchestrations where multiple agents can work together and do a full resolution workflow end to end without having customer interactions, where customer can go ahead and set their preferences, and based on previous customer interactions, those multiple agents can take the actions on the customer's behalf, depending on to do a reservations or refund or rescheduling or cancellations, which means again without having any human intervention in the loop. And that's a long-term vision for this architecture, where we can automate every action the customer can take so that based on the customer history, customer gets full exceptions or full experience of how they want to utilize their e-commerce platforms in any world. With that, I would like to close the presentation with summarizing the points, and I want you to take the points with you, and so that you can use this in your architecture decisions when you implement any remediation platforms. Number one is the exceptions are inevitable in any complex systems, and at millions of orders per day across multiple channels, some of the orders will fail. And that's not the problem to solve. The problem is to solve how we handle those exceptions and help the customers. Number two, the traditional agent-centric model cannot scale. It is linear and it is a structural bottleneck. The solution to this is architectural, but not an operational. You don't need to hire more people to fix the problem. You have to design a system which does not require that much, but solve it systematically. The third one is the system triggered self-remediation, where you shift the controls and give the controls to the customers in a proactive fashion without having any agent in the loop, which means the systems and customer can interact directly, and customer gets more control and gets more confidence on the system. Number four, this is a paradigm that creates simultaneous values for both customer as well as organizations. And it's a rare case where the efficient thing is also the right thing. With number five, the pattern is transferable. You can use the same pattern, the same architecture across multiple domains. It could be healthcare, banking, telecom, travel, or government services. The same kind of exception predictions or same kind of exception resolutions can happen productively in any of the domain available, where end users can directly interact with the systems, and this architecture can help solve the problem. With that, I'll close with when the system finds a problem and gives customer control right away without waiting in line or talking to an agent, it does not save time. It does more than that. It helps the customers to get what they need faster. And for some people, solving the issue quickly can make a big difference in their life. That's why the systems that we build or the architecture that we design are so important for our customers. With that, I would like to conclude my presentations, and I'm happy to take any questions that anybody have.
Mr. Ratra, for presenting, and we sincerely thank you for your valuable contribution. Thank you